Welcome all to today's session. The agenda for today is we'll be covering threat hunting, alert analysis, and remediation using IBM Security QRadar EDR. Now, before starting with threat hunting, I would like to recap on the QRadar architectures for folks who have joined us today for the first time. So QRadar EDR architecture is a simple two-tier client-server architecture where the clients are the simple agents that are deployed on endpoints which are connected to Hive Brain, which does the smart logging, data collection, behavioral analysis, and all business logic stays here on the server part. Along with that, we have a console optimized remediation workflow that gives you an intuitive GUI for working on any type of alerts and managing your infrastructure. Now, let's move on to threat hunting. Now, we'll first look why threat hunting is important, what does it play a role in your cybersecurity arrangement. So suppose you receive an information, boom, you have just been attacked. The bad guys are in your system and they are hemorrhaging the data. Now, this was not an isolated incident. There was a time that led up to this, and there was a time that happened after. So, I have plotted a timeline throughout which this event will be plotted. So, the time that led up to this, going back and preceding, we call as left of the boom, and the time after it, when we try to discover, that's the time we call right of the boom. So in the first phase, basically the bad guy is doing reconnaissance. He's looking at your systems, he's probing them, he's trying to figure out where the weak spots are and where the good data is. And the time after the boom is where we are doing recovery. The problem is we don't always know when the boom occurred at the time it has occurred. There's a lag between a boom and an alarm. This is when we found that an attack has occurred, which is not always the same as that of your boom. So, what could we do about this? Well, there's a time here which we can see that is mean time to identify what the problem is. According to the Ponemon Institute survey in 2023, the mean time to identify is in the order of 200 days. Yes, you heard it right. It's about 200 days. That's how long it takes to figure out that bad guy is already in your system. And further still, there's this notion of mean time to contain, which is in the order of 70 days. So we put this together, it is about 270 days in total between when the boom has occurred and the time to contain this attack, or we finally got everything recovered. There clearly would be some advantage if we could go back in time and discover the boom and bring the interval between alarm and the boom closer together. Or even if we could go back to the boom phase and start to recognize the reconnaissance phase, that something is amiss. Something is happening in this phase, and this timeline is the area where we could be doing what we call threat hunting. I could do a threat hunt, and we'll talk about what that involves after a hunt, which basically is an investigation or incident response. Remember, the incident response here is reactive and threat hunt is proactive. So that's the biggest difference here. So, as much as possible, it would be nice for us if we could go back the boom phase, that is to the left of the boom, and anticipate some of these things. Now, how does it work? Well, it turns out that we are going to take, if we are doing threat hunting, we're basically going to develop a hypothesis. You have some actors acting as an investigator, but they are investigating things that may not be fully happened yet or in the process of happening. So no alarms have gone off yet. So what are we going to use? What we are going to use is the things like indicators of compromise and IOA, that is indicators of attack, which we can gather from our systems that tell us that someone has done something wrong here and may have caused a breach. Maybe it's a small hole here and there. There are other things like indicators of attack that may be here in as well. It says someone is knocking at the door. They might not have fully gotten in, but they did some things that we should be concerned about. The other source of information would be security intelligence threat feeds. So Intel feed tells us that there are certain types of vulnerabilities that are being exploited on internet these days, and certain things that are happening maybe in a particular sector or a particular geography. This is security intelligence. We would like to use that kind of information and leverage it to the best of our ability as well. So if you remember during COVID times, there were lots and lots of reports stating that the pharmaceutical area or domain is the one which is highly attacked or major area of interest for cybersecurity attackers. So then we could do some vulnerability scans on our environment that would tell us what the bad guy is also seeing, and that there is vulnerabilities here and there in your systems. These systems are weak here. This is the soft underbelly. This is what the bad guys are doing. So why wouldn't we do the same thing? So then an intelligent threat hunter who has some experience and some insight into this is going to use basically their experience and little bit of intuitions to connect these dots and say things that seems isolated in fact are not. They are all grouped together. We connect the dots and we realize before the boom has occurred that in fact this is the setup that's about to result in a data breach. Or it could be in this range of time when some things may have already been attacked, but the alarm hasn't gone off. But we are going to see telltale signs, and those are the things that we are looking for. We would ultimately want to take all of these technologies together, infuse them with AI, so that we can get to a point, find the source, get our investigation done faster, and do the reporting. Hopefully, uncovering this issue before the boom, and if not, at least very soon after the boom. Because what we are trying to do is avoid two numbers. The first one is 270 that I initially talked about, the days to identify that we are being attacked and the days to contain. So that's a huge number. And second number is the number or the cost of breach, which is in terms of 4 million. So according to that Ponemon survey, 4 million is the average cost of data breach, and that's what we are trying to avoid by threat